Hey everyone, welcome to another Microchip live stream. I am your host, Matt Dickens, here with my co-host today, Xavier and Richard, and we're going to be talking a little bit about Trust&GO with the connection between Microchip and AWS. I know Xavier, you've been here before, but Richard, could you introduce yourself and tell us a little bit about yourself?
Sure, my name is Richard Elberger. I'm a Partner Solutions Architect in the IoT segment in the AWS Partner Network. Been at AWS for a bit more than 4 years, been working with Microchip about that time as well.
Okay, awesome. So he's going to got a lot of great information about how to get connected with AWS in an easy and secure way. But before we get started, I'm going to send us back to the booth, and Rachel and Clifford will tell us a little bit about how you can get involved today.
Hello, good morning.
Good morning, guys.
My name is Rachel Bedore, and I'm here with Clifford SWARTZ. How's it going?
Very good, how are you?
Good. It's early, but I'm all right. So today we are giving away 5 of the DM320118 development board. It's a crypto auth trust platform development kit. It's super new, super awesome, so we'll have 5 of them, so comment in the chat and we will enter you to win.
Absolutely.
And just make sure you're asking questions and we will be relaying them to our hosts. But if ever we don't reach your question, you can always send us an email at livestream@microchip.com. And yeah, anything else, Clifford?
No, I think we're good to go. I'm excited.
All right, thanks guys. Back to you, Matt. Thanks,
Rachel. Yeah, and great pronunciation of livestream@microchip.com. I've still never got that right, so good work, Rachel. So Xavier, before we kind of dive into the specifics of today, do you want to give us a little bit of a summary of embedded security? I know we've talked about it in the past, but just to give a quick update or kind of introduction.
So if we look at embedded security, right? I was describing to the guys yesterday, it's kind of a layer cake where you have multiple things that you need to take care of. And if you build your cake from bottom to top, you'll start with that root of trust. That's where your keys are and needs to be protected. Then you're going to have to take care of your firmware. If we talk about the base, you're going to do 3 things to your firmware. You're going to make sure it's genuine at boot. You're going to verify your firmware at runtime. And you're going to verify your firmware after an update, after an over-the-air update in the case of IoT. Then you're going to go into the communications. And when you communicate data from an embedded hardware to a cloud entity, you want that pipe of data to be encrypted. And Richard will talk a little bit about TLS and the practices AWS recommends. And then at that level, make sure I haven't forgotten anything. I think those are your basics. And at that level, it's the world of software and cloud security.
Cool, awesome. And when we talk about security, what is actually being secured in this setup?
Okay. So in the setup we're going to talk about today, right?
Yeah.
So setup we're going to talk about today, we're going to focus on that very, very basic layer, the base layer. Without that layer, a lot of things can get corrupted. So that layer is that root of trust. That's where those keys, mostly the private key, is going to be protected into a secure element. We had many sessions that we talked about of secure elements. So a secure element is a secure enclave that has anti-tampering and some side channel attack protection where the keys are going to be provisioned. And that's what we're going to talk about today.
Okay, awesome. And then just one more technical phrase, provision. When we talk about a key being provisioned, what does that mean?
Very simple term, in very simple ways. Provisioning a key into an embedded device, it's basically how you place the key into the embedded device.
Okay.
In mass production too.
Okay.
So doing that for prototyping is one thing. We're going to show that live today. But then we're also going to talk, I think, at the end of the webinar, how do we do that by millions and millions of units per month, literally.
Okay, great. And then Richard, from the kind of AWS perspective, what does it mean when I talk about authenticating a device?
Yeah, sure. So with AWS, when you're connecting to AWS, there's 2 parts that you need to take care of. One part's the edgy side with the device. The other part is the cloudy side, right?
Okay.
When you're dealing with the edgy side, what we need to do is have all the pieces in place in order to have a TLS 1.2 connection with AWS IoT Core.
Okay.
We require transport layer security 1.2 to ensure that our customers are not prone to attacks such as brute force attacks and also man-in-the-middle attacks. All right. In order to achieve that, we need to have the root of trust on the device, what Xavier just talked about, and we need to generate a certificate for that device. So when the TLS 1.2 communication happens, then we can present that certificate to the AWS cloud.
Okay.
In order for the AWS cloud to understand who you are, that certificate needs to be registered in the AWS cloud.
Gotcha.
Right? So what we've been working with Microchip on over the last few years on several different fronts is simplifying or reducing the friction of that process of getting those certificates up into the AWS cloud so you can have that secure connection. So really it's two parts. Getting all the software in place on the edgy side, and then ensuring that we have all the automation, low friction parts in place up in the AWS cloud.
Awesome. And so we've got hardware, software, and the cloud all represented today. So that's going to be a great discussion. So I guess from the, geez, I'm blanking on here. Sorry, guys. We talk a lot about automation and kind of making that process of creating certificates and keys and all that kind of stuff as automated and as easy as possible. And I know Xavier, Microchip's been working on some things to try to really streamline that process a lot. Can you tell us a little bit about that?
Yeah, absolutely. If you guys can switch to my display. I want to show, so that's what we've launched late September, if I'm not mistaken, early October this year. So what we've seen in the industry is frictions to onboard with certificates and secure authentication as a whole. Certificates, if you work with third-party certificate authority, will cost a lot of money. The IoT marketplace is very fragmented, so not everybody can afford that. Even it could be argued to be a good practice, it's pretty expensive. So how does a company that has 3,000, 10,000, 50,000 parts per year can afford those certificate authority? They just don't. So that's where unintended security flow are being created by building your own CA, and then you don't know how to maintain it, and this and this and that. I mean, it's an endless discussion from that point. So what we launched with Microchip is exactly that three-tier platform. It's called Trust&GO, Trust Flex, Trust Custom. It's all part of the Trust platform family. So what this is, it's a family of devices that leverage our secure provisioning or in-house secure provisioning service in different shape or form. Trust&GO is pre-provisioned with a generic certificate. That is, when you buy the device, you get the device and a manifest file. It's a JSON file that has the public set of information related to the private key that will be inside the device. TrustFlex is also that, but we allow the user to change those credentials, to override them if you want to. And TrustFlex, let's scroll down a little bit, offers much more use cases than just device to cloud authentication. The third tier here is Trust Custom. Trust Custom is basically a fully customizable device that can become pretty much anything in terms of authentication use cases. So we bring a lot of flexibility of choice for the customer when it comes down to choosing a secure element that is pre-provisioned, pre-configured, or fully customizable.
Okay, awesome. And I know we've talked about a lot in the last 5 minutes, so just a quick recap up to this point. You have an embedded device like Xavier has here. On that embedded device, you have what's called a secure key, and the embedded device and everything around that embedded device is kind of in place to protect that secure key. Then you have what's called a certificate, and you have to have some kind of an authority that's creating those certificates, or those certificates have to be coming from somewhere. And what Trust&GO is kind of, it sounds like, helping to support is that certificate creation process, and then also kind of how do we move those certificates from Trust&GO to AWS, which I think is what we're going to be talking about next, right?
Exactly, and that's what we've been able to reach on.
Cool. So how do we interface with AWS from that side?
Yeah, sure. So there's, again, let's do a deeper dive on the cloud and the edge side because they work hand in hand. One part is the certificate provisioning. How do we get that certificate into the AWS cloud in a friction-free way, right, on both the Trust&GO, TrustFlex, and Trust Custom? The other side of that is how can we interoperate with the secure element on the edge to make that secure connection, right? So let me cover off the first part, which is how do we get that certificate registered? up in the AWS cloud. With Trust&GO, we developed a system to easily import those certificates into the AWS cloud. We're going to be talking about that process in detail later on. With TrustFlex, we implemented a system called Jitter, just-in-time registration, to enable a simplified way of the device connecting and then giving AWS a certificate to verify and then register that certificate in the cloud. And that will also work with Trust Custom as well. Now, to get to that point, you have to implement firmware on the device, right? And depending on the device that you're using, there's different ways to implement that, okay? So when you're talking about an 8-bit device, what customers are doing today is they're leveraging things like the MQTT client and also the TCP client. That's not the the TCP client and the SSL libraries that are on the WINC1510, for example. And they're using, for example, the embedded C SDK on the microcontroller, right? And then they're writing code to interoperate with the secure element to get that work done. So those are like 8-bit devices and also brownfield devices.
Okay.
And you can use the embedded C SDK. We do have FreeRTOS and Amazon FreeRTOS, which implements a PKCS11 layer, which enables transparent interoperability with the secure element. We launched that a couple of months ago with Microchip. And then finally, what also integrates with the secure element is when you're working on larger microprocessors like the SAM-A5D2 and AWS IoT Greengrass, there's hardware security integration, or IoT Greengrass HSI, and that enables our customers to use a PKCS11 interface to integrate with the secure element to secure their root of trust on those larger microprocessors.
And when you say PKCS11 and FreeRTOS and things like that, what is that actually referring to? Kind of at the 10,000 foot
Yeah,
level.
sure. So let me just, I will simplify it. So PKCS is it's an acronym, and I won't go through like what exactly it means, but it simplifies the APIs that you use and standardizes the APIs that you use to do cryptographic operations with things like everything ranging from, it started in the smart card industry and then expanded out to other things like secure element.
Okay. Cool. So it's going back to kind of how do we standardize the security side of things.
That's right.
Okay.
Awesome.
Awesome.
And it's widely accepted in the industry.
Okay, cool. So that sounds like that's from the software side, and then from kind of the embedded side you were talking about was the second piece.
Yeah, that's right. I mean, they have to work hand in hand, right? So.
Okay, cool. So I know we've talked a lot about kind of Trust&Go so far, but I know as an engineer I like to be able to see things working before I can really fully understand them. So I know Xavier's got a sweet demo for us today, and we're all expecting it to work perfectly live. So here we go. You want to show us kind of how Trust&Go works?
Yeah, definitely. So the what we're going to try to demonstrate, and we're going to pray for the demo gods, right? So I've tried that last night, and you'll see why when I tried that last night. Yeah, there's something that are going to overlap. So it works. That's a good thing. So let's show everyone how to start and how to turn. So my hope is to show you literally we can turn months into development in 2 minutes. It's a big statement. Hopefully it'll work. So let's get going. If we want to switch to my display, perfect. So out of that website, the Trust Platform website on Microchip, you can go pretty much on all the pages of the Trust Platform, and you'll find, for example, if you go down to the Trust&Go AWS page, you're going to find that little button here, install the Trust Platform Design Suite. So what the Trust Platform Design Suite is a software that'll help you to work with the secure element. And I'll show you exactly what that means in a second. So when you click there, you're going to get pointed to a user manual. Read the manual. I'm going to repeat, read the manual. There are very specific instructions where you want to install the Trust Platform. If you don't install in the path we recommend, you will probably have problems. So again, third time, read the manual. Download the package there, install it at the right location, and what's going to happen on it works for both Windows and macOS, obviously. Once I've installed my Trust Platform, what's running behind, it's really something called Anaconda. So if I go to my Anaconda here, I'm going to launch it. So I've already launched it to avoid consuming time on loading. What's going to pop up is an image of your desktop. So if you see here at the top, I have the folder architecture of my desktop, really. and I'll navigate from the Trust platform into the design tool. So let me actually do it. So here's my Trust platform folder that I've installed at the recommended path that I showed before. I'm going to go into my design tool, and here are all the different flavors of Trust Flex, Trust&GO. Today, I'm going to focus on the Trust&GO. I'm going to Trust&GO, and the first thing we'll want to do is to generate the certificate based on the kit that I'm showing. The kits and the boards we're showing, this is what you're going to use for sampling, really. There is not really a notion of samples. You have to either get the kits and run through what I'm going to run through, or get devices as you go to production, because the devices will come with the manifest. How do you get the manifest from a kit? You'll have to create it, and that's exactly what I'm going to do.
And what's the manifest?
So, good point. So the manifest is, as you provision those private key, you need to make accessible the public sets of credentials that relate to that public key, which is the public key, and also the serial number of each devices. So now, how do you distribute, actually a very good question, how do you distribute those serial numbers and public keys associated to every single unique device in an order that's 10,000 pieces, right? So you need a couple of things. You need an e-commerce store. So we have Microchip purchasing store, and we've partnered with most of the distributors in the industry that when you buy or device through those e-commerce stores, you also get that manifest JSON file with a public set of credentials. You get that when you buy the devices. You don't get that when you get the kit. You'll have to construct it. And if we switch back to my screen, that's exactly what I'm going to do in a minute. So the Anaconda environment uses the notion of notebook. Notebook, you'll identify notebooks with this extension IPYNB. Let me click on it and I'll see what's inside. So what's inside is basically Python running behind. The idea is with just a few clicks, we are going to create this manifest and handle that quite nicely. Before I do this, what I have to do is to go to my board, plug it, of course, plug my board's turning on. I'm going to go to my IDE, and I'm going to have a factory firmware. I'll explain why in a second. So I'm going to go to Tool here, Device Programming, selecting my tool, going to Memories, and I've already done that yesterday, so it should point me directly to the resource generation folder. Sorry, not the resource generation folder, the assets folder, and here's my factory program X folder where I'm going to fetch the X file, and I'm going to program my microcontroller. So what's happening here is the microcontroller the firmware we're programming into the microcontroller is necessary to help constructing that manifest on the hardware kit. And that's what's going on right now.
So you wouldn't do that during production?
No, exactly. This is only for prototyping with the kit. Like I said, for production, you'll get the parts, you'll get the manifest directly from the e-commerce store. There is no need to do any of that.
And that's actually a really good point as well. As we're kind of going through all of this, is that what we're talking about today, we've talked a lot about security at scale in the past, and we'll talk about that a little bit at the end. But this is, as far as I can understand it, one of the first options really out there to start prototyping and making security, specifically and embedded security, accessible to really the mass market as a whole, because all these tools are freely available online when you go ahead and you buy the kit and stuff like that. And so while this is not like, hey, this is how you production level do this is a great thing for somebody who's just getting started with embedded security.
Let me change the security by secure authentication.
Or secure authentication.
And you'll see there are a few things we have not implemented in that kit just for the
okay,
sake of
secure authentication.
Yeah.
Perfect.
So I have my factory firmware now, and I'm in my notebook, the resource generation notebook. So I'm just going to run it. The way you run it, you go to your kernel, just sanity check is clear all the outputs. And going back to kernel, restart and run all, and then that's when we hope it works. Let's see.
We know it's going to work.
It does work. Here's my manifest. Everything is getting created, and I have the success message here. The manifest has been generated, and that's the name of the file. The file, we'll see in a minute where it's created. It's created in those folders. So now, if I want to be literally selfish, being this product manager for secure elements, I can stop right there. I've handled my secure element. I'm done. literally a few seconds, I am done. So I have a private key, my secure element, I have a manifest file, and I've provided you, the user, that file with the public key and the serial numbers. I can stop right there. It doesn't help much the firmware engineers where you need to put all the stacks together. That's what Richard was talking about a few minutes ago. Now what we're going to do is bring that into a fully embedded system with the microcontroller and connectivity and cloud. So the next step here is to go back to my, I'm going to close this window here. Go back to my Trust Platform folder, my Trust&Go folder, and I'm going to focus on the AWS Trust&Go use case. Now what we're providing here, if you look at the folder architecture, we have a notebook. That's going to be basically the same philosophy of what we just seen with resource generation. And we have a C folder. The C folder is where we'll have the image that will be programmed into the microcontroller. Start with the notebook. What the notebook does here, and I'm going back to my IPYNB, you can ignore the other files. I'm going to launch it. And then what this thing will do, it will upload the manifest. And let's run it. So again, for sanity check, I'm going to clear the outputs.
So where does it upload the manifest?
It will upload the manifest in the AWS IoT environment.
Yep.
I'm going to run all and hope for a second time that it works. Does it work?
Looks good.
So there you go. So here's something that that had to be done behind the scene. You see those access keys and secret keys? I'm not going to show them. I'm going to show you which folder and which file they are. And you need to make sure when you create an AWS account, you'll have your, and Richard pitch in anytime if I'm saying anything wrong, you'll have those access key and secret access keys that represent the credentials to access to your accounts, your cloud account. So now you need to pair your cloud accounts to that embedded system. The way we have that set up, I'm going to go in my resource generation.
Yeah, just to be a little bit more specific there, so users in AWS have what's called IAM accounts,
Okay.
Identity and Access Management.
Okay.
And when someone is granted an account, they should only be given access to what they need to have access in AWS. When you're generated that user, you can create an access key and secret key for that specific user, and that's
Okay.
what he's talking about there.
Yeah.
Okay.
Thanks for the clarification. If I want to go back to my laptop, so here's my architecture where I'm still in design, the Trust Platform folder, design tool, and in the docs. So that docs is where basically here are my credentials. Again, this is prototyping only. That's all it is, nothing else. Don't do that in production. So going back to my, so I've set up my access key and secret access key, and that's what you see the end, the last few digits of my access keys. You see my region too. I actually messed around an hour, I wasted an hour for setting up the wrong region on my AWS account, so I had conflicts. So make sure you set up the right region. You will have to be, do you want to talk about the whitelisting now? Or?
No, we'll talk about
Okay.
that next
Okay.
when you show the
Okay.
web pages and stuff.
Okay.
Yeah.
So for my region, I'm going to have to set that up also on the embedded side of things. So in the user region, I'm going to make sure it's US West 2, click enter, and now it's starting to pair the access key, secret access key, and the region to the system. Now to upload the manifest file, I'm going to go and fetch it. You remember we just created it in the previous step, and here it is. You know, it's that JSON file that's in that resource generation folder. It's been created. I'm going to make it ready to upload. The second piece of information you'll need is that certificate, that logging certificate.
And that was also generated by that last Jupyter.
Exactly,
Okay.
exactly. And then the last thing is to upload the manifest. And now we should see some action right there. There you go. So now you can see the manifest have been uploaded into the AWS IoT environment. Now what's happening is you have a certificate that's ready, that's waiting for a signature to come to verify that signature. So we've, if you want to switch the camera back to me for a second. So what we've done, we have created the manifest. We have provisioned the device, created the manifest, uploaded the manifest. And the next step will be to take care of implementing the right firmware on the microcontroller and show a connectivity to AWS IoT. I think we
Great.
had a question.
Yeah, do we have a question in the booth?
Yes, we do.
So thank you, Xavier. You showed us a really good demonstration of this, and so you've kind of answered this question a little bit. But Luther David A. Hall asked, he's kind of asking, how does one learn the process from scratch, and are there any one-stop resources from Microchip to supplement your development?
One-step resources.
Where would they go for information?
Oh,
when
okay.
they get done with this?
Okay. So for all of that, we'll well, first of all, that onboarding will be on YouTube. This live stream, so that will be one of the resources. We have everything that I'm showing here is what you have when you download the design suite, the Trust Platform design suite, which is available on our website. You do microchip.com/trust platform, and pretty much everything is there. And you'll have many other use cases that talks about IP protections and key rotations and stuff like that, also part of that design suite.
Awesome. And do we have any more questions? I actually thought of one as well, but do we have any more questions from the booth?
No, sir.
All right. So I think since we're already paused, a good question that I keep asking myself is, this seems like a lot of work to do for someone who's just getting started prototyping or just getting started with an IoT solution. So why would someone who is working on their first IoT design and they have a plans to take it to market eventually, but they're for sure not there yet, why would somebody take the time to go through this process and add a secure element to their device at that level in the process?
Yeah, I mean, you've seen it's the fundamentals of security. Security is kind of it's kind of having a car insurance. You don't need it until you need it.
Okay.
That's pretty much what it is. One of our apps manager described it that way. If I wanted to stop there, I could just stop right there. It's literally a life insurance, a car insurance. You need it when you need it. Until then, you just hope for the best. But in the past, 4 years that IoT started to pick up, and IoT is now in production. The next level of difficulties, the first level of difficulty was connecting to the cloud, so protocols, type of communications, both on the embedded and the cloud side. I mean, Amazon has done a ton of work and investment to make sure all the protocols are well supported, different method of authentications are too. The next level of difficulties is security. So now, how do you start on this thing? And what's happening is it's natural. It's a natural cycle. You tackle a problem, you get bugs into the COM stack and whatnot, and now the next level of bugs are going to be an exploit, or going to be at the security level. We've seen a huge increase of attacks, and there are two populations that attacks those things, or the black hat, white hat. White hat is certainly researcher that get paid on paper to be publicized, and that's all they live really, and they do that for the greater goods to evolve the security technology.
Yeah.
And you have the black hats that will do that for generally ransomware with the financial rewards behind it. So do you want to be subject to that? Hopefully your business will be successful. If your business is successful at a global scale, it will be attacked. It's just a matter of time. If your business is successful, that means you have volume of things around the world you're selling over. That becomes a global surface of attack. And that's what the hacker wants. They want the size of the surface that they can tap into to propagate an attack across the globe. I don't know if you want to pitch one.
Yeah, I'll just add on to that. So there's a couple of different parts I want to tackle. One is that when you're not protecting, like you're creating a device, and the device becomes very popular, and you're selling millions of them, it becomes a target by hackers, right? And if someone can take your root of trust off of your device and then use that private key to connect to like a cloud solution wherever, and then impersonate you, that's a challenge. And the Microchip technology protects against that, right? Because it's immutable and it cannot be taken off the secure element.
Yeah.
The other part, why you want to start earlier rather than later,
right,
which goes to your point, is that when you identify that you need to protect your root of trust and that you need to do cryptographic offload in order to have faster TLS connections with the AWS cloud, you'll find if you do that, it'll be challenging for you to refactor your design in later in the cycle.
That makes sense.
It's a really great opportunity for everyone on the live stream today to take a look and say, hey, how can you improve your design in from the get-go?
Yeah.
You actually open another door. So that's normally what security experts will answer to that type of question. There's a second answer is the logistics. There's the logistics of security. So imagine all those millions of devices that go from a 32-bit microprocessor, microcontrollers. all those keys, those private keys, are unique per device. So let's say if you do a dishwasher and you have 1 million dishwasher that you're about to ship and they're all connectable, each of those 1 million dishwasher will have a unique private key. What have you done there with your dishwasher? All of them are customized because of the uniqueness of the private key. How do you ship a customized system all across the globe? It's very expensive, and we have data points, and that's all just because of that private key, that set of key, I should say. We have data points that you basically just below the dollar range, just to put a private key inside a microcontroller, forget security. So there's a huge cost to do that. So by offloading that customization chunk because of the uniqueness of the private key, or system or manufacturer or factories equipped with HSM, that's what we do. 100% of our business is custom business.
Yeah.
So what you have on your little system here, that's what our microprocessor team has done. They have a traditional microprocessor, traditional Bluetooth Wi-Fi connection, and then they have the secure element that handles the customization off board. Now, from an economic standpoint, your system remain economically viable, and the economics are not impacted by the customization of the device.
Because that device is
Yeah.
changing from a software
Exactly.
perspective, not from a hardware perspective, but from the firmware. Yeah. Do we have another question in the booth?
Yes, we do.
Yes, Pablo asked, in case of a breach of the security, how would you update the keys on both sides, AWS and on the embedded device?
There are default techniques, actually.
What was the question? Can you just ask did you say update the keys? I just want to be clear about what the...
Yeah, but if, so he said, how would you update the keys in both sides, AWS and an embedded device? But if there's something relevant you want to talk about, that could be helpful too.
I just want to clarify the question because I don't know if it's like a terminology challenge or something like that. We don't update keys up in the AWS cloud. The private key that is your root of trust stays on the device. So the only thing that could possibly change that's both on the device and in the AWS cloud is the certificate, right? So can we ask a more clarifying question to the person if that's what the...
Well, I think, and we get this question a lot. We get various versions of this question, so I think it's a good question, but it kind of goes back to, once again, the understanding of keys and what, when we say key, what we actually mean. And so, correct me if I'm wrong, but doesn't the ECC family generate a private key every single time? Like, isn't that the key, like, generated?
You could do that. The US has the capability, the Trust Custom would have the capability to do that, but that would be a bad practice because if you leave the capability open, that's your backdoor, basically.
Oh,
you can change
okay.
that. But what we implemented in the Trust Flex variation is close to your idea, whereas we still have that parent private key. Yeah, you do bet on the quality of a secure, or the capability of a secure element to protect that private key. The Trust Flex is set up to do private key rotation if you want to. So you'll say, hey, my slot 0 is my parent private key, and it'll authorize slots 1, 2, and 3s to rotate the keys. There are humongous consequences that are extremely costly and hard to manage to implement on the cloud side of things to do that. And that's where Richard was saying, actually, we don't talk about key rotation too much, but you renew the certificates, and there are several methods to do that.
So why I wanted to clarify it, because it seemed like the attendee was asking if we synchronize keys between the edge and the cloud.
Good point.
And we're not putting keys in the cloud. To go to Xavier's point, if we rotate the private key, that means another certificate signing request will need to be issued and then put to the AWS cloud. Somehow another certificate would have to be issued down to the device, and then you use that for the TLS 1.2 connection. So there's a whole other sub-process that would also need to be implemented in order to facilitate that.
Gotcha.
And so what we've seen in the industry that opens a good door, we had discussion, I think, this morning with Richard, rotating certificates. There are several school of thoughts that we see happening actually from the Microchip side. We see the cloud company like AWS offering more and more complete service like that, and Richard is himself a solution that if you're interested, reach out to him after the live stream. If not, we've seen a surge in the certificate authority industry where they will provide a certificate management service, what they'll charge for it. And the certificate management service is rotation of certificate, renewal certificates, revocation of certificates, and auditing your certificates.
Oh wow. Okay.
So
Yes.
that,
Cool.
that exists, and the TrustFlex device is really suited for that.
Okay. Great. So I guess the easy answer is use a secure element so your private key doesn't get taken, and then you
Yes.
don't have to worry about it.
That's right.
Hopefully, hopefully.
No, I say that somewhat facetiously, but in all seriousness, I think that is like a really good point to pull out of everything that we just said is use a secure element or something like that is its sole purpose in a lot of ways is to protect that private key, because it can be such a challenge if that private key becomes public. And historically, and we've talked about this on previous live streams, but historically the way that those private keys were kept private was literally on Excel files or in text files and things like that. And those really can be a huge problem when that becomes lost, whether it's to a contract manufacturer or gets lost in an email chain or whatever. Like if something happens to those, it can, just like we talked about, cause some huge challenges on the back end to try to fix that problem. And so that's really why we're talking about secure elements and why we're trying to make them as easy as possible to use, is because of the challenge that it presents if that private key gets lost.
Let me go to the next step
Yes,
and
please
actually
do.
program our microcontroller if we want to switch back to my laptop here. So I'm going to my IDE, and remember I showed you there's a C folder next to the AWS notebook, and that's exactly where I'm going to go and fetch there. So I'm going to open an existing project, and here's my Trust&Go folder, AWS use case. I'm working with Studio right now. It works also with MPLab. And here's my file, my AWS IoT ATSLN. I'm going to open it. It's going to bring the whole project here with us, right? It does.
Because the notebook that you ran through also creates C files and header files that have that information to help facilitate the process, so, like your IoT endpoint and so forth.
Let me see, why is it not popping up? It was popping up when we did so.
You need to restart. Oh.
Oh, there it goes.
There you go. So
Yeah.
Building. So what I've done, basically, I brought up the file. I don't know why it was not showing up. It showed up somewhere. It's hidden somewhere.
Yeah.
So what I've done in that file really previously, so you can see the firmware is being programmed in the microcontroller. What I've done previously, I set up my, if you want to switch the camera back to me,
Double click.
there. So I've set up my access point here. I have the SSID and the password that are placed into the code. And I also have added the AWS endpoint. I'm going to show you in a minute where the AWS endpoint is. So my firmware is now programmed. I'm going to go into my AWS account. So that's for Richard. So if you go to AWS, I'm going to go back to the original, the landing page of AWS. So that's my landing page. I'm going to go and find the IoT core. And then within IoT core, we are going to see actually that certificate that is part of a thing. And the way I go there is,
Secure.
I was going to go first. Let me do one thing first. I'm going to show the endpoint. So that's the endpoint. I went to setting, endpoint, and so that endpoint is what I brought into the firmware file. And then you told me to go to secure. And proceed. And here is my certificate. Let's take a look at it. So now that I've programmed that,
So the issuer says, what does the issuer say? So that's like,
I forgot to say something before. So
okay.
I did forget to do something.
Okay, one moment,
Yeah.
please.
So I have my microcontroller here. I know we have a question. I'm going to finish that before we take the question. I'm going to plug my Wi-Fi into my board here. So I have my microcontroller, I have my Wi-Fi, everything is in place. I have one last thing to do. I'm going to launch, before I launch that, when I launch my GUI, I'm going to need that unique identifier here. So I'm going to, copy the unique identifier, launch my GUI. There you go. And before I do anything, I need to enter my identifier. It's initializing. And what should I access to this? What? Ah, got a problem there. Demo gods are not with us.
We're running so well so far.
That was the last step. So I don't know what's happening. Let me go back to verify this, because I've done that last year. It is not connecting. I don't know what's happening. So
And it could be like a local Wi-Fi
Yeah.
challenge. So, because I was having challenges here for a little bit.
Yeah.
So
Well, this room is a dark hole when it comes to Wi-Fi stuff.
yeah. So while Xavier's like looking at that, you want to see the
Yeah. We have a question in the booth.
Yes, we do.
Yeah, so we actually have a few questions. I just want to say a lot of really good technical questions. And if we don't get to your question today, because we might run out of time, just don't feel bad. Send us an email at livestream@microchip.com, and we will forward it to everyone. But we did have a question, and Richard, I thought maybe you could speak to this a little bit. So we talked about the support offered by Microchip and how to get started with the Microchip embedded side of things. Can you tell us a little bit about the resources from AWS?
So so the resources, can you be a little bit
So like what websites or different links or things could people
Sure,
They
thank you.
specifically said tutorials.
Right. So there's a few things that we have. First of all, there's the API documentation. So everything in the AWS cloud is REST-based, right? So you
Okay.
use web services. So there's all that documentation. Everything in IoT Core everything in the AWS cloud is accessible through REST services. The second part is the user guide documentation, right? So the user guide documentation is there for every single service that we deliver to our customers. The next is that we do deliver at regionally and also at lofts worldwide, workshops,
great.
trainings, that sort of thing. So find out where your nearest loft is. For example, we have one that's continuously going in San Francisco, one that's in New York.
Okay.
We have pop-ups worldwide, Tokyo, Berlin, London, that sort of thing.
Great.
Another thing is we've just started releasing some free IoT training. That's up on our website. Unfortunately, I wasn't prepared to bring a link on that today.
No
I probably
problem.
should be prepared, but if you look for AWS IoT training, and I believe it's being delivered by the Training and Certification Organization, so it'll be somewhere in there in the AWS website, you'll be able to find that. Also, one last thing, if you're working with microcontrollers and you're working with FreeRTOS, because Richard Berry, who invented FreeRTOS, is now part of AWS, we're curating the freertos.org site together
Okay.
for connectivity. So you can go to the freertos.org website. You can see that just recently, Richard set out in his newsletter that they have upgraded the navigation on that site and put in additional documentation.
Oh, awesome.
So that will really help those that are working on microcontrollers and building solutions on top of FreeRTOS.
Great, there you go. And we'll make sure that we include in the description to this video as many links as Richard shoots over. So if you're watching this after the fact, please check the description and you should be able to see a lot of those good resources linked from the description to this video. You said we have a couple other questions?
Yeah, I'll ask another one while Xavier is troubleshooting. And if this doesn't apply, don't worry about it. You can send an email. So Jared asked, do these concepts apply to other services, i.e. if I rolled my own server and self-signed CA infrastructure?
yes, absolutely, absolutely, yeah, absolutely. So if you have your self-signed service, that means you want to use your own certificate chain. So then we'll recommend you to look into the TrustFlex form factor. The reason we offer the Trust&GO is for companies that don't know how to handle certificate authorities or don't have their own certificate authority. So absolutely, yeah. At the end of the day, you have a certificate chain with a private key into a secure element with a TLS network. That's all you get. The platform around that, it's your choice.
Great. Is it working or?
I think it is.
Okay,
Amazing.
we're back. We're back.
It is.
We're in
Well,
business.
I got the connection to my hotspot, so we'll see if it gives me. There you go. Here's my GUI, and we'll see if my LED is blinking or not. Let me test that. No, it's not blinking. No, I got a problem with the connection here. So I was hitting the hotspot here. There is something probably that's overlapping what I've done last night. I was expecting some conflicts, and they are happening, of course, now that we're live. So at the end of the day, what you have is, as part of your AWS environment, you're going to have your thing. That's where basically you're going to see your certificate that we just uploaded. So that upload worked. It probably has to do with the config of my hotspot or something. And that's it, really. So the difference with just-in-time registration and that trust and I would call it the multi-account registration implementation that probably you need to talk about in a minute. You don't need a full certificate chain to, maybe I'm abusing the words, to run this authentication. The Trust&Go will only rely on the device certificate to verify the signature that's going to be presented. The TrustFlex architecture using just-in-time registration relies on there's an intermediate signer that has been used to create a device signers. That intermediate signer is also called a signer certificate, is the one verifying the device signer, and that's why you have that just-in-time mechanism to bring the device signer into the AWS accounts. Those are two differences. When you go with the just-in-time registration architecture, that means you have either bought or created a certificate chain on your own. Companies who don't know how to do that or can't afford that, you look at the Trust&Go solution where we provide that little certificate with the associated to the private key. Do you want to add anything to multi-accounts, maybe?
Yeah, so I would only add that, like Xavier said, it's really two schools of thought. If you want complete control over the way that you handle your PKI, then you would go with the Trust and Flex, right? We've had the technique called bring your own certificate. What that means, you're bringing in your own CA. The constraint for importing certificates into IoT Core to do that authentication that we talked about earlier is the issuer CA certificate needs to be registered with AWS IoT Core. All right, and there's a process in there in AWS IoT Core that that reinforces the fact that only CAs that you can register are ones that you own and operate. Okay, so those security constraints are in place. For those that don't have their infrastructure, there is a new technique that we have. Actually, it's a feature that we released into beta that's called multi-account registration. One of the reasons why we released that feature was to enable customers to register the same certificate across multiple accounts in the same region. That used to be a constraint before. But as a byproduct of that, what we found is that technique also helped out the Trust&Go situation.
Okay.
So in the context of that same beta, and Xavier has a couple of web pages up to show you how to get registered for that. That enables you to import a certificate. The constraint in the bring your own certificate case, in the prior case where you used Trust and Flex, was that you had a CA registered. The constraint in this particular case is that the person importing the certificate must have those IAM credentials that I talked to you about in order to import that certificate. So that is the constraint in that particular case.
Okay.
The side effect of that, of course, is that you don't have any of the PKI controls that we talked about earlier, but it's a trade-off when you're doing this.
Totally.
If I pause you, it is working.
All right.
We just had a huge latency.
Okay.
So let's pick it back to where I was. So when I launch my GUI, right, I have to copy this unique ID into the field here, execute the GUI, and then here's basically the example of my shadow register. So if we zoom on the board here, I'm pulling up the GUI that's right there. I'm just going to toggle that. There's one of the LED that's going to go on and off. So from the GUI of my laptop, it's going to AWS, back down to my hotspot, hitting the Wi-Fi, and that's here working. Yeah. Again, we can observe the shadow register directly on the Anaconda environment. You can go to your AWS account and look at the same thing. And here's the statement we've done, right? It really takes several weeks, if not, we've seen up to 4 months for normal firmware engineers to understand what's certificates, what's a PKI, what's a chain of certificates, how does it work with a private key, do I need to rotate keys and certificate and yada yada. In a few minutes, we literally implemented the entire thing. It's for Trust&Go, it's baked into the price of the device when you buy it. We give you the file through our e-commerce stores. It's loaded on the AWS accounts, and we've done that. I'm a marketer and I've done it. So it's
So
here.
easy a marketer can do it and fix it apparently when it goes wrong.
Yeah, there you go.
Great. So I know we've got just a little bit of time left, and we've been saying all day this is not for mass produce. This is not for mass produce. So let's take a couple minutes just at the end and let's scale this up. So I know we used the magic number yesterday of 100,000 units. So Richard, how do we move from this, from the AWS perspective, how do we move from this to where we have one certificate authority getting uploaded to the cloud? This is all kind of done for one, and suddenly multiply that out to 100,000.
Yeah, right. So when we started this conversation with Microchip on this particular solution, one thing that you might realize about AWS is the first thing that we always think about, well, the first thing we think about is security.
Okay.
The next thing that we think about is how can we scale out solutions? So the
Sure.
first conversation that we had with Microchip was, how can we do this but scale it? So we worked back from the scaling part.
Awesome.
So we solved the scaling problem first. What we envisioned was, we're not going to have engineers sitting there importing certificates into AWS IoT Core. Right. What we want to do is enable folks that are maybe operational folks, maybe folks that are administrative, not on the technical administrative side, but just like project managers or whatever, right? Anyone, and make it so simple to import these certificates. So we devised a system where, and it's not a huge system. It's a very, very small microservice type or serverless based type system where all you have to do is drag and drop a file into an S3 bucket. S3 is just a very simplified way to manage object storage in the AWS cloud. Drag and drop that file into the bucket, and it'll go and import all these certificates for you.
Oh, wow.
So you're not working with the AWS IoT console. You're not working with stuff on the command line. You just run a CloudFormation script. It puts in a couple of configurations in the AWS cloud, and you just drag and drop that file. Someone who has those IAM permissions. Right, so the security context is important. So we need to have that security constraint there for the logged in user to do that. Yeah. Great.
Well, that's like barely any work to go up to a lot, so that's great. Start with the end in mind, as they say. All right, we have talked about a ton today, so for those of you that are still with us, we really appreciate it. I know that this security is always a heavy topic, and Xavier does a great job of trying to distill that and make it as simple as possible, but it can still be a challenge. So I'm just going to try to recap this, and then they're going to correct me when I inevitably say something wrong. But so we talked a little bit at the beginning about the high-level purpose of this is how do we make secure authentication available at the prototyping level to somebody who can come in who has fairly little experience with it and get started. So first we talked about the embedded part, and when you talked about embedded part on the red board that you have there, is that the ECC608, or what actually microcontroller have you been using on this board?
Good point. Yeah. So we have our ATSAMD21-XPRO on the board right next to Cortex-M0 SAMD21.
Okay. Cool.
The reason we've done that, we need to show with the most traditional microcontroller cores how you can implement secure authentication. Nothing else. We actually, what's interesting is our sister business unit from the microcontroller group, they have actually this nice wireless SOM here that has their SAM-A5D2. We have a combo Bluetooth Wi-Fi, and the secure element, the Trust&Go variation of the secure element is embedded. So when you buy the wireless SOM, you get pretty much everything and all the designs already pre-made. It's really cool.
Great. That's nice. So we have a couple different embedded options, but essentially what we've done with this Jupyter script is the Jupyter notebook is generating all the middleware, I guess. Like, that's probably the wrong word to use, but all the things that go between AWS and the microcontroller.
The mechanics that needs to happen with a certificate, an embedded system, and a cloud environment. So how do you move all those three pieces together and start to put them together? That's what the notebooks are really doing.
So the Jupyter notebook is essentially taking the place of a security expert at the prototyping level.
I wouldn't say that's.
But I would have, I would almost said yes.
I would say the way I would put it is that it removes a lot of this repetitive task from the developer, right? So if before the design suite was put into place, even myself, I would work with engineers that work on crypto-auth-lib and stuff like that at Microchip, and you would have to go and discover all those APIs yourself, write the automation yourself, piece everything together, and there was a lot of testing that was required in order to get it just right. And what Microchip has done now is put those scripts in place. Not only does it work for you to do your prototyping, but it gives you a starting point for writing your own scripts too. So it simplifies a lot of that stuff that actually, I would say, created some friction when you're trying to develop your solution.
Okay.
Yep.
Great. Yeah, that's a much better way to put it than I did. Great, and then at the end we just talked about kind of where do you go from this Jupyter Notebook when you're actually talking to the AWS cloud, and kind of how does that final piece fall into place. And like I said, I know there's a lot here, and so we'll make sure to add all of the links and description in the description of this YouTube video to make sure that anything that they could possibly need to get started is included in that package. So if you're watching this after the fact, or if you want to come back, probably want to watch this live stream a couple more times to fully get all the nuance of what we did today, and those resources will be in the links in the bottom. So with that, I'm going to send it to the back of the booth, and if we have any last questions, please feel free to ask, and if not, then I think we have some live stream winners today.
So we actually have a lot of questions, and I think we're going to tell everyone just to send us an email at livestream@microchip.com, and we will forward it to Xavier and Richard. So with that, also send us an email if you're called as a winner, and I will announce them right now. So our winners are Atmosphere IoT, Carlos Treviria Davila, Norm Nelson, Pablo Pacholetto, and Jared Munch. Send us an email and let us know you're a winner, and we will process your prize. Congratulations.
So in that email, we will need your name, your address, and your phone number. And if we're unable to ship to your country, we apologize, but we will do our best.
Thank you, and thanks everybody for a great chat. Lots of great questions.
Yep. And don't forget to like, comment, subscribe, and hit the bell if you don't want to miss any more of these live streams.
Yeah. Great. Thank you all. In the back, thank you, Clifford and Rachel, so much for this. And I will announce, to my chagrin, this is actually going to be my last live stream. I'll be moving on to do some other things. So I've had fun with you all the last couple of years that have been with us since the beginning. Jared, I know you've been around for a while, and I'm sure we have some others on the chat who have been to most, if not all, of the live streams that we've put on. So it's been fun, and I'm excited to see this continue to grow. And with that, if you enjoyed today or any previous live stream that you've seen, please feel free to share that with your friends and your colleagues and things like that. The best possible way to kind of get this information shared is to share it via, WhatsApp, Facebook Messenger, whatever online communication tool you use. We would love to get this information out there because we do this for you guys and girls at the end of the day, so that people can get started with security and wireless, and we'll probably end up doing motor control and lots of other really exciting things. So please share this with anyone who you think might be interested in getting started with embedded security, IoT security and secure authentication. And with that, I think we will call it a day and see everyone next time.